Differentiation from first principle.
Okay, so with respect to WASI concept, today we'll be looking at differentiation from the first principle. Differentiation from the first principle. Now, the process of finding the general expression for the gradient of a curve at any point on the curve is known as differentiation. The process of finding the general expression for the gradient of a curve at any point on the curve is known as what? Differentiation. So what we are trying to say here is that with the equation of a straight line, anytime you have a straight line and you have points, let's say A, let's say B, and let's say here is C. If you find the slope, so what happens is that the slope or the gradient of the length AB will be the same as the slope of the length BC because it is a straight line. But when it comes to a curve, you have to find the gradient of the curve at a particular point. So let's say you have a point of the curve here A, you have a point of the curve here B. So we just draw a line which is tangent to that curve, and the gradient we find to the line at that very point is what we call differentiation. It's what we call differentiation. Now, when you have the straight line, the slope we find is sometimes represented as m, which is equal to what? Change in x over what? The change in y over what? The change in x. But when it comes to differentiation, it is the derivative of the y divided by what? The derivative of the x. Because with the differentiation, we are dealing with the slope of the curve at a given point. So the same way, we can also draw a line which is tangent to the point B, and we find the slope of that particular line or that particular curve. And how do we do it? How do we go about this? We can use the idea of the first principle to find the derivative. Okay. So now, if you have the curve of this nature, let's say A, and find the gradient here, what happens is that the gradient will depend. The gradient will obviously depend upon where we are on the curve. So the gradient of the curve always depends where we have on the curve. So suppose we want to find the gradient of a curve which is equal to y is equal to 5, y is equal to f of x. We want to find the gradient of a curve which is equal to y on f of x. And this curve is in the Cartesian plane. So let me draw the Cartesian plane here. So this curve is in the Cartesian plane. And what happens is that this is the curve on the Cartesian plane. There's a point here, let's say this point is PQ, and let's say this point is Q. Now, we want to find a gradient at a point P. Now, let's say the coordinate of the point P is x, y. Okay, so that is here, f of x, and to make y value of x, so now I need to do that. So now we said y, so this is y. So y is what? F of the function f of what? Of the x. And let's say the coordinate of the q. It will make a certain particular distance. Are you getting it? So now the coordinate of the q here becomes, let's say it's x plus h. Because if you can join the q and the y as a straight line. The q and the y as a straight line. So the coordinate of this place will now become the f of what? X plus h. So you have coordinate of q as x plus h, bracket f of x plus h. Okay. So now this is the curve f of x. Realize that there are a lot of points on this particular curve. And depending on the point you have or where you are on the curve, you can find the derivative of the curve, which is called as what? The differentiation. Now, we know that with our simple mathematics, if you consider the line PQ, then the slope of PQ will simply become what? Our change in the y over our change in what? In the x. So therefore, considering line PQ, we have our m, which is the gradient. What is our change in the y? So this is the length of the y. So the length of the y here becomes what? The f of x plus h minus what? Our f of x. So which is f of x plus h minus our f of x. All divided by our change in x, which is our x plus h minus x. Which is our x plus h minus x. Now, when you do this, what happens is that we will get m equal to our f of x plus h minus our f of x divided by x plus h. So the x plus h minus x will give us what? Will give us h. Okay, so we can find the limit as h approaches 0 of the gradient m. So if you find the limit as h approaching 0 of the gradient m, what you are getting is that the limit of h approaching 0 of f of x plus h minus f of x divided by h. And this limit we find is known as the differentiation. So the dy dx from the first principle is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And this is what we refer to as the differentiation. So I want us to take only example, yeah, and I end this lesson. Okay. So the first example says that using the first principle, we should use the first principle to find the derivative of a function y is equal to x squared. We should use the first principle to find the derivative of a function y is equal to x squared. Now, when we say y is equal to f of x, so x squared is a curve. S squared is a scale. So now the function, if it is x squared and the coefficient of the x squared is positive, you have a curve like this. If the coefficient of the x squared is negative, then you have a curve that comes this way. So you know that almost always a quadratic function gives a curve. Okay. So now since the x squared is a curve, we can find the derivative of the x squared. We want to use the first principle. Okay, so now our f of x now here becomes our x squared. And what is our f of x plus h? That is changing the whole of x to what? X plus h or squared. Okay, so when you get this, we can now easily find our derivative over here. So now what is x plus h? It's the same as x plus h multiplying x plus h, which will give you x squared plus 2xh plus h squared. Okay. So now you state your formula. The derivative dy dx is equal to the limit as h approaches 0, the function f of x plus h minus f of x all divided by h. So now we just put it inside. The limit as h approaches 0. What is the function? F of x plus h is what? The whole of this, which is x squared plus 2xh plus h squared minus f of x, which is what? X squared. All divided by what? Divided by h. So now when you simplify this, the y, the x. Okay. So when you simplify this, the y, the x, you'll be getting this x squared can take this x squared again. So you get 2x h plus h squared all divided by h. So the limit as h approaches 0. So therefore, the dy dx now becomes, you can have limit as h approaches 0, which is 2x over h divided by h plus h squared on h. So you divide the term by the denominator. So h, you take this away, h, you take one of this h away, leaving the last h, which will give us our dy dx equal to the limit of h approaching 0, 2x plus h. So this is the limit, finding the limit of a simple function. And it becomes easy because h is approaching 0. So if you put h 0, you get 2x plus 0, which will give what? 2x. So that means anytime you have a function y is equal to x squared, and you have to find a function, the derivative of the function y to x, you will get what? 2x. You get 2x. Try your hands on this example. So example 1, y is equal to root of x. And example 2, y is equal to 2x squared plus 3x. When you do this example, you have the dy dx to be 1 over 2 root of x. So try your hands on this example. In the next video, I'll give the answer to this particular question. Thank you.